Shalom IT lovers of my classes, welcome to Data Analysis, DAVS Machine Learning ML Part 5. Right now I'm not going to do the whole big translation in 3 languages because I'm busy translating something else. So I'm just going to do the practice, with the comment, in English. All right, let's start. Still on data analysis vs machine learning. Now I'm scrolling, top to bottom, bottom to top, just to remind you about what we have done so far. We have imported the necessary libraries and, data generation, creating a dictionary with sample data for fruits and vegetables, data frame creation, a pandas data frame, and then we could display the basic statistics and information, and describe info head. We could print all these, and then visualizing the data, the count plot for the fruits, the count of fruits and vegetables, and then count plot to visualize the distribution of different colors in the data set, and then a plot of weight and VS price. Scatter plot, we did some grouping and aggregating data. As you can see now, I'm starting now with the correlation matrix. After the bar plot of average price by type, we can start with the correlation matrix. I hope you remember how we, we could create and manipulate the data frames using pandas to generate statistics, visualize data distribution, perform grouping. And now we are going to analyze this correlation between numeric variables. For those who don't know what the correlation analysis is, well, here's the correlation matrix. Here is to calculate the relation between weight and price per kilo. Here, in general, the definition of correlation matrix is that the correlation matrix is a statistical technique used to evaluate the relationship between two variables in a data set. It's a table in which every cell contains a correlation coefficient, where 1 is considered a strong relationship between variables, 0 is considered a neutral relationship, and -1 is considered a not strong relationship. This is what the correlation matrix is. This is what we want to see. So we start with the command. I prefer the correlation matrix than the confusion matrix. I hope you remember we saw this confusion matrix in our iris flower machine learning analysis, a classic one. And here we are seeing this one. So I accepted also the suggestions of the system, but I'm going to correct some things. Well, here it's called, the command is called core underscore matrix equal df, and then weight in grams, price in kilo, and then I put the dollar because it's easier to count in dollar, and then print the correlation matrix, and then we want a heat map of the correlation matrix, meaning that we want to see this correlation matrix using heat map. So it's going to be a plt.figure fixed size. All these codes are a lot of these are shortcuts, talking to the machine in code, because I don't understand sentences like we talk. So this coding this is what it's all about. So this is what we see. You can see the the 0, the 1, then as I told you, the relationship between yes, I was as I said, between weight and price per kilo here. Okay, so we are good with the data analysis of vegetables and fruits, you see. So now we are going to start the machine learning version. I hope you remember that we are still comparing. And after that, I'm just going to move on with DA, as I said. So right now, I was just showing you that on the left pane of Colab right here, the directories, there is nothing. Now it's empty. And now we are starting machine learning with big data set generation, really big data set generation. And, I put also some, fruits, exotic fruits like, what did I put? Papaya and all this stuff. I also love exotic fruits and vegetables. Now we have cherimoya, ananas, coconut, saba saba, and of course apple, bananas, etc. And then I wanted to add more, in the data set. And of course also the vegetables. We have a large data set with, potatoes, cucumber, manioc, spinach. We have zucchini, we have yam, we have some radish, some platanos, and the color and the size and the texture and the taste and the shape, and they tell you if it's exotic or, general, common fruits and vegetables, which most of people know. And then I wanted to convert all this generated data set, which is really a large one, here in a data frame 2 because it looks better. And then we save them in two different CSV, one for the fruits and one for the vegetable. As you can see, yes, it's already done. As you can see, we generated that. And yes, we are going to move on now. After we have saved them, and then we are going to take a look at them. But first, we want to load this data set and print it. We have to import pandas as PD, and then we're going to load the first data set, which is going to be, fruits and then vegetables. And here I think I emphasize that it's important to put the right path of your created CSV, or else you're going to have a problem. So this is what I'm doing here in inside these parentheses. Vegetable underscore data equal pd.read underscore CSV in parentheses. You put the right path, and you don't forget about these quotations. All is so important here. And then we want to concatenate the two data sets, you see, and we have to indicate how we want to concatenate them. We want to concatenate them vertically. So, and then we want to print them then, and we make sure that we want a certain output. Like right now I want the index with name, color, size, texture, taste, shape, exotic, and then dtype equal object, and then print, then we want to print the combined data. And here I'm showing you the ones we have generated, on the right hand side, of the screen. You can see the vegetables and the fruits. They are two different data frames there. And they look good in data frame. That's why we do the data frame. But when they are combined, it doesn't look like that. But I just wanted to show you that we can also concatenate here, all the things we can do, in all these language programming. We can do also here in DA and ML. I think DA is very, very interesting, but I just wanted to remind you that I'm still comparing both coding techniques. And here is the part I'm showing you is the vegetable part. So on the top, when you combine, when you concatenate, not easy word, when you concatenate, you have the fruits on the top and the vegetables on the bottom of the list. And in data frame, they are separated. Okay, this is it's going to be it for today. The rest is going to come next. We have a lot still to do, a lot of commands here in ML, but we have done that before, so it's going to be easier. I just wanted to show you that you can, see your CSV live, and you can also concatenate them. All right, so next time is going to be the main coding. We will have to, import libraries again. All right, you all. Thank you for watching. I didn't mean to drop it like it's hot. And I hope you liked it, or you could learn something, or have refreshed your memory with something you forgot about. Anyway, the rest is coming next. God bless you. All right. Bye-bye.